Yes! Hello, and welcome to another episode of the Art of Engineering. In today's episode, we are going to see the trials and tribulations of repairing this masterpiece of stereo hi-fi from the 1980s, the SANSUI AU-417. Let's go! The 1980s, a time when all our action heroes were larger than life. The 1980s was also a time when a strange little man slid around in his socks and his underwear. Speaking of larger than life, it was a time when stereo systems were also huge. In fact, people boasted about the size of their stereos. If you look at stereos today, there's something that's supposed to blend into the background or disappear and be very understated. But in the 80s, when greed was good, everything was about size. Size mattered. And if you went into someone's house, the speakers were huge and the stereo systems were massive. And this amplifier here has arrived care of my cousin. And it's a beautiful example from the 1980s. It's a SANSUI integrated amplifier AU-417. And like all things coming out of Japan in the 80s, the switches and the dials on this thing are absolutely a joy to operate. And it would be a huge shame if we couldn't get this thing going, because it's on the test bench at the moment because it is blowing fuses. And let me tell you, I have had a real journey of rediscovery of fault finding at component level via this amplifier. And what's fantastic about it is it's got screen printed circuit boards that clearly indicate base and emitter junctions of all the transistors. You can isolate boards by unplugging them, so you can actually fault find to board level quite easily. And once I worked out that this thing was blowing fuses because one of the channels had a shorted transistor in it, I was on the way to discovering a fix for this thing.
Okay, folks, this is something a little bit different. Please excuse the hand filming. This is beautiful, chunky stereo amplifier from the 1980s. As you can see, a good old school linear power supplies. For all you young'uns that wonder why all this gear is so heavy and so chunky, well, one of the reasons is because the power supplies are your traditional linear power supply. So until about the 1980s, probably getting into the 90s, we started to transition to what we now know as a switch mode power supply. That's our trusty old switch mode power supply over there, which I've done a story on my ham channel playlist on how I made that a little bit quieter, because one of the advantages of a switch mode power supply is they're a lot more efficient and they're a lot smaller because they use a lot smaller transformer, but they tend to generate a lot of RF noise. So there's ways around that, and they've certainly gotten better over the years of filtering that and getting rid of that disadvantage. I don't think we're ever going to go back to old school linear supplies, but for those of you who are interested, who haven't watched my channel, I will quickly show you something that I have done on my channel. In fact, we'll go right over there now. A bit of a quick shack tour. The bench that I'm building, which is on a shack revamp video. But you can see underneath here, running my shack and all the DC requirements is this beautiful, quiet linear power supply. It's a 20 amp supply using two rewound microwave transformers. The design is care of Drew Diamond, homebrew legend VK3XU. And that's running all the DC requirements for my shack. And we were doing a little bit of FT8, but not really getting anywhere tonight. It's a rather miserable old night, but it's always lovely and warm and wonderful in the shack. Anyway, back to this. So we have our chunky transformer, because in a linear power supply, we don't chop the AC up into a higher frequency, which if we make the HF a higher frequency, we can shrink down the transformer. So we're using our normal 50 hertz supply frequency, which means we have to use a large transformer, and we also have to use larger filter capacitors and whatnot. So when I opened this up, the symptom was that it just keeps blowing fuses. So he's put a few fuses in, and I think he's blown about 3 of them. So we may have other dead components. What I'm hoping is that that's not the case, but you know, we can hope it's against hope. Usually if something goes high current, something is going to be taken with it. But opening up, I looked at the schematic. There's a number of things that could go wrong. One of the more obvious thing was these 2 capacitors here that look like they've crapped themselves onto the board. First I was worried that might be an adhesive to hold the component down, but none of the other capacitors that are like it have any adhesive on them. So I am assuming that this has crapped itself, and certainly the solder pad on the other side of the board looked like it was a little bit corroded as well. So this may very well be a little bit corrosive in its nature, what was coming out of this. God knows what that is. It's probably very nasty. They're 220 microfarad capacitors, electrolytics at 63 volts. So I've gone and got capacitors at the same rating. Modern capacitors, a lot smaller. When I changed the electrolytics in my TS520 Kenwood boat anchor rig, they were a lot smaller, way smaller. Video on my channel. But fingers crossed this fixes it. I could get lucky, you never know. Anyway, we're going to solder these in. They're electrolytics, so they need to be put in the correct way. I did note which way they came out, but the board is also marked very nicely. It's screen printed with which is positive and which is negative. And for those of you that don't know, you may be just starting out in electronics repair. I am by no means an expert, and I am not advocating you follow my lead. And you must also understand that inside this thing, once you take the covers off, you're exposed to 240 volts, dangerous voltages. And if you do any of this, you do so at your own risk. Anyway, the longer lead is the positive, shorter lead is the negative, and also on the can, you can see that the negative lead is indicated by that stripe and the negative symbol. So you can always work out which one it is. So let's pop these in, and we'll see if the fuse keeps blowing. And there are our 2 capacitors. I'll flip this over now, solder them in, and we might pop a fuse in and wind the volume right back and just see if anything goes pop. Yay! While I was nattering to you, we've worked station 3,000 and a bit kilometers away. Call sign 3D2, 3 Delta 2, Uniform Sierra Uniform, and we'll jump on. I think I've worked him before. I think he's on one of the South Pacific Islands. And yes, I have worked this station, very memorable in fact. It's a special event station in memory of the fallen king of Fiji. So, wonderful event station, and obviously a big signal, and I've gotten him on a few occasions. So, Bulavanaka. Capacitors soldered in, we'll just remove those excess leads. What we've noticed is when we measure across the capacitors, here, the filter capacitors, we're getting about 8 ohms or so, which I think there's like 70 volts across there from the positive rail to the negative rail. So that is really low. And when we start isolating either the right or left channel, pull out the supply here, nothing happens. But watch what happens when we pull this one out. We end up with an ohms reading of 7 kilo ohms. So I would think that that board on this side may be the problem. So what we're going to do is we're going to put the power supply back in position, leave that disconnected, throw a fuse in, and see if we still manage to blow a fuse. And if we don't blow a fuse, we might be sailing in the right direction. The fault's after the supply. We will check voltages on the supply as well if we can get that going. Okay, let's see how much smoke will come out. Oop, power protector. Oop. The power is staying on, so it's no longer blowing the fuse. So we're a bit closer, hopefully,
to finding a solution to this problem.
So we're making a little bit of progress. I've got the amp out of here. I'll just show you the heatsink that it came off. That's the heatsink that it came off. So it's obviously, going to be getting pretty warm. And I don't know if you can actually see it there, but if you look at the legs on both of these transistors, they are very, very brown, like they've been scorched out. So that's a really good hint that there's something wrong with them. But when I test these with this component tester here, and this has been a fun thing to have, and this is testing the transistors on the other channel, you can see that it does this little test and it's telling you that that is a transistor. When we run the same test on these transistors, it's telling us that it's a resistor. So, and a very low ohm resistor. So that's probably our problem, if not the entire problem. So I've gone on a website and I've ordered some components.
So that's the transistors I bought. I've actually bought 2 of those. So it's cost me about $26, free postage, and they will be arriving from China around November. So I bought an extra pair because if I plug them in and they still explode, I'll just go and dig around a bit more. But I will be changing the electrolytic caps on that board because they're probably well due for a change. Happy days. We were told this would be arriving November. It's actually sort of pretty late October, but it's arrived early. So we're going to get this open and we're going to have a look at what transistors have been sent through. I'm assuming that these are perhaps old stock or even used stuff that's been ripped out of other devices. So we will give these a bit of a test on the component tester to make sure that they are operational. We certainly got plenty of them because I was a little bit nervous about my repair skills. It's stuff that I haven't worked on before, so I thought I'd give myself a fighting chance by ordering way more than I need. And should capacitors or other things go in this amp later on, I've got more for another channel should I need them, because I haven't recapped this entire amp, and I probably should if I wasn't very lazy, but I'm kind of a if it works, don't muck around with it sort of guy. So that sometimes works in your favor and it sometimes gets you in trouble.
And that is the other. So 2 transistors.
And there you have it, folks. 2 newly installed power transistors. There's an NPN and a PNP pair that go on this channel. Each channel has the an identical setup. So we've presently got one channel that seems to be working. So the deal is now just get a load of this this heatsink, man. It is awesome. So we will clean off the heatsink compound that's sort of boiled onto there. Get a nice clean surface, reapply some heatsink compound, and reinstall this channel, and then test to see whether we still have the same shorting condition that we had previously. Now, when I switch this on, transistors might blow. We might be back to square one. I'm hoping not, but we shall see. Okay, it's back on the bench, and we need to get these screws in. A bit worried I wouldn't remember which way it all goes back in again, but this is a great thing about gear that was built in this day. The cables sort of tell you where things should go back. These days, if you take something apart, anytime it's a good idea to take photos, but in this instance, I probably could have gone back to the video that I'd taken. So I always do take some video to make sure I know how to put things back together again, but it wasn't necessary. It was quite obvious how it all fits back together again. But it's certainly a work of art internally. The Japanese definitely knew how to build stuff to last. And what it lacks maybe in the elegance of some of the more modern systems you see these days, I can honestly say that it's certainly rugged and designed to last. These days the the little push button switches and whatnot you find in a lot of this gear. You look at it and you know that you're buying a stereo system that's going to last you, max 7 or 8 years before something fails on it and you won't be able to replace it. This thing is as good as the day it was built, almost, by the looks of things. But hey, I'll reserve judgment until we get it going again. Oh, the joys of fault finding. We cranked up the amplifier after last night's success. We did have 2 channels, and I thought I was going to be heading towards putting the covers back on this thing, but you check your bias over here, and we had one channel that was very, very distorted, and when I cranked the volume, especially when that channel was engaged, the protection circuits would kick in, and a huge amount of distortion and whatnot. So biasing issues. So this TR6 transistor and these components around here, these capacitors and this variometer, this pot, are likely culprits, but the transistor's definitely got an issue, so we will be swapping that out. You can't get that type of transistor anymore, so I'm going to go with an equivalent, slightly different pinout, so we're going to have to do a little bit of jiggery pokery, but hopefully we can get this thing operational. Well, we are finally back on the bench, and I had to put in a different type of transistor because the transistor that controls the biasing on this channel is, I don't know if you can see it there, but the 2SC945 is no longer a very easy to find transistor. It's just a simple NPN audio transistor, and the pinout's emitter collector base. Now, they said, well, I managed to find out that a BC546 is a fairly good equivalent transistor, but it has a different pinout. So what I've had to do is, before I've actually started to put it in, I'm hoping this is in focus, but at any rate, I've managed to leave 2 legs in the same order they are in and crossed one across. Now, this comes with its own peril because you can actually short 1 lead or 2 leads out to the other lead, etc., etc. So what I've done is I've thrown some heatsink on the leads, and I'll try and zoom in on that when I do this video edit to show you what I've done there. It's very, very messy, admittedly, but I've removed 2 of the leads. I've left 1 lead in the board so that the lead I crossed across, I could solder to that tag there. And I had to remove this heatsink, and so I've reapplied some paste as well, and then I've metered to make sure that when I'm moving stuff around, that these transistors here and this one here as well don't short to the actual heatsink. So I also got my trusty multimeter out on continuity testing, and I just made sure that leads are not shorting to other leads. So that was something I did, as well as checking to make sure that it doesn't short to the heatsink. So now we are in a position where we can wire this back up, chuck it back in, and then I'm probably going to do a video on setting the bias and the DC offset on the left and right channels of this amplifier. That, I think, will be a useful thing to have up online. So I will also, in a moment, in fact now probably, jump over to the actual circuit diagram just to show you the area of the circuit we're dealing with and what that's all about. So let's jump over to that schematic now and have a quick look. Please pardon the hand-carried filming. This is the circuit diagram, and in here you have your biasing circuit. You adjust this VR3 to change the bias. Now, at first I thought the pot was dodgy. I took it out and tested it. It seems to be all right. It's changing values like it should. But when you put it in here, there's no change in the bias voltage when you adjust the bias like on the other channel. I do know that this transistor was definitely dead. The base emitter forward bias was not correct. It was not looking like a transistor. What's really good about the circuit board in this amplifier is it actually has base emitter on every single transistor, indicated on the actual PCB, screen printed on. So it makes it very, very easy. So now this I know is working. I've changed that electrolytic capacitor that goes across there. The thing is, this is still not working. Now what I've done is I've come up here to TR5 and TR7, and TR5 is a dead end. So that's the next transistor that needs to be replaced. So here we are with our transistor tester and testing that component. It looks like it's two diodes, one with a forward bias of 4.38 volts and one with a forward bias of 749. So that might be a very good reason why the biasing circuit is not switching on. Well, it's finally arrived in the mail, and as bad luck would have it, as usual, if it's an $800 transceiver, the postman leaves it in the middle of the lawn. If it's $20 worth of parts, he'll take it back to the post office and make me have to pick it up. Well, I guess it's a good reason to leave work early. So we picked up the necessary parcel, and it was on the way past the bottle shop. So we get ourselves a 6-pack of beer as well. Low carb, of course, because I'm a fat bastard. Anyway, we need to put this transistor in. I got, Wiltronics. I thought there's no point in just ordering one transistor. Let's order some other fun stuff as well. So let's have a look at what's in here. Some transistors. I got some of these panel mounted DC jacks that I plug into, because it's just nice to have a few of those for up and coming projects. And I didn't want the ones that mount on the PCB because they're a pain in the ass. And we've got ourselves those transistors. I bought a few because you never know, they might blow up when I first put them in. Nothing more frustrating than only buying one and then realizing you screwed it before you even start. And we also got some BNC connectors as well for future transmitter builds and transceiver builds. And what else? And yep, that's another one of those. I got 2 of those because you can never have enough of those. Building rigs all the time. So that's what we got. Is there anything else in here? Yes, a big staple that's sticking me in the finger. The plan is to meter out all the other transistors on here and see how many of them have failed. No doubt we'll be putting an order in for some more transistors. But this has been a really fun wander around 1980s style electronics. So much more serviceable, so much more fun. I'm kind of thinking now that this era of electronics is the era that I want to play with, because it is still so doable and there's so much quality gear out there that deserves to live on. Now we've got the multimeter in the diode test mode, and like I was saying, it's really clear where the base emitter is on these transistors because they screen printed on here. So I'm just going through the whole circuit, and if I test here base to emitter, you can see that's 0.7. Depending on whether it's PMP or NPN, you've got to sometimes change your polarity. That's not giving me anything at the moment, but it was a minute ago. We'll go the other way around. Interesting. There you go, 0.7. So that one's working as well. This one here, base to emitter, 2.3 on that polarity. So I'm assuming that it'll be 0.7 or so on this one. There you go, 0.7. The only one that's a little bit sus, and I've got to stop swapping my leads around all the time because I twist myself up. The only one that's causing some problems here is this one here. When I read it base to emitter, it's giving me 0.374. And when I go the other way, it's also giving me 0.37. So I would say that that transistor is a dud. The only other thing I've got to test on here that's, I've tested the diode already, that's testing okay. The only other thing that might have blown is this FET, and I'm hoping it hasn't, because that might be a real pain in the ass to try and get hold of. I might actually try and clip the, it's a double FET, but I think that feeds out of here into the other channels. So I am assuming that that is okay. So what we need to do is we need to solder this transistor in that we've just put in, and we need to pop TR9 out of the circuit, stick it in the tester, and see if it's as dodgy as I think it is. Because I have a sneaking suspicion that that's going to be a problem transistor. Okay, get this in. What a fantastic chassis this is. I mean, you could drop it off a building. It's like a Hilux, Toyota Hilux from the 80s. Literally indestructible. I think there's another amplifier that's got a lot more channels or a lot more features in it. And there's space here for 2 more filter capacitors and another transformer over here on this side here, which you probably can't see. But this is the option without all that stuff. But still a wonderful amp. I think the 517 might be using this chassis as well. But yeah, just a joy to work on. I've got to say, such a Mr. Bean today. Yep, the plan now is to, once this channel's reinstated, is to get the bias set up on it so that we're happy with the bias. So hopefully the bias comes back online. If it doesn't, there'll be other problems on this channel that I need to sort out. But if we can set the bias and the DC offset to 0 on each of the channels, we should be plain sailing from that point onwards, and we should have an amplifier that works. So fingers crossed that this will be my first successful amplifier repair. And this is most of the parts that needed to be taken out to make the damn thing work. Okay folks, a little bit of advice on the adjustment of bias on this thing. First thing you need to do is obviously make sure that your volume is down as low as it will go. And you are looking for around 20 millivolts. I would advise you go to the relevant pages in the service book, but I think it's 20 millivolts plus or minus 1 millivolt. And the test point, as you can see here, is labeled plus and minus. If you get it around the wrong way, it'll just give you a negative polarity. But yeah, you've actually got it. Everything screen printed on these circuit boards. Absolutely wonderfully designed. A joy to fault find on, even for an idiot like me. And the bias pot, that's this one here. So you've got one here and one at the top. I'll just pan up so you can see the one at the top here. There's another pot that I'm pointing to just there. And that is for the adjustment of the DC bias. And this pot here, which is not the original pot, I had to change it. The one I had issues with the wiper and whatnot. That is the one that you adjust to get to your 20 milliamps. So I will just switch this on and I'll show you the actual value. I am not going to twiddle that pot because I have finally got this thing working and I don't want to tempt fate. But just give me a second, I'll pan the camera down. And there you have it, 19.75, close enough to 20. And they do advise you to leave it for 2 or 3 minutes to let it settle down. But hey, I will twiddle the pot just to show you that it does vary with the pot. I've got the screwdriver in there. If I go to the left counterclockwise, it should go down. You can see it going down very slowly, down to 19.6. If I go clockwise, it should take us up to close to 20 milliamps. And there you have it there, 20.01. There we go. So that is how you adjust your bias on the SANSUI AU-417. Now, if you want to adjust the DC offset, which is to make sure there's no DC sitting on the actual output, audio output, like I was saying, there's a pot, and I'll show you that pot again. I might even try and get closer to it. And I'll show you that pot again. This is the original one. It's just there. So you put your probes in the back of the audio channel, plus and minus, either left or right channel, and then you adjust the respective pot. I can't remember which is right and which is left. You should be able to work it out. Volume down, put the probes in the back, and adjust for 0. Thank you for sticking around right to the end of the video. It's been a lot of fun. Hope you've enjoyed the video. It's a little bit different, but I've really enjoyed servicing and looking after this brilliant piece of technology from the 80s, through whole components, 80s electronics, a lot of fun to service. It's made me realize I want to do a lot more of this. So what I've done is I've gone off and I've bought myself a whole lot of test gear, digital storage oscilloscope, a new multimeter. I've already got a small spectrum analyzer, a vector network analyzer, component testers, etc., etc. So I'm going to set this space up, and that's going to be the next video. So hit the bell notification, hit the like, hit the subscribe, and I shall see you in the next episode of The Art of Engineering.